For a distributed shared memory solution to be useful, it must provide good performance to applications. If we think about the core service that's provided by distributed shared memory systems, accessing memory locations, then it's obvious that the performance metric that's relevant for DSM systems is what is the latency with which processes running on any one of these nodes can perform such remote memory accesses. Clearly, accessing local memory is faster than remote memory, so what can we do in order to maximize the number of cases where local memory is accessed versus remote? One way to maximize the number of local accesses and achieve low latency is to use a technique called migration. Whenever a process on another node needs to access remote state, we literally copy that state over to the other node. This makes sense for situations where we have a single reader, single writer, since only one node at a time will be accessing the state, so it does make sense to move the state over to where that single entity is. However, this requires moving the data, copying the data over to the remote node, and that incurs some overheads. So even for the single reader, single writer cases, we should be careful when we trigger these types of mechanisms, because if it's only going to be a single access that will be performed in this other location, then migrating, copying over the entire state over to node 4, it won't be amortized. We won't get much in terms of low latency improvements if we had to copy all the state just for a single read or write access. For the more general case, however, when there are multiple readers and multiple writers, migrating the state all over the place doesn't make any sense since it needs to be accessed by multiple nodes at the same time. So a mechanism such as replication, where the state is copied on multiple nodes, potentially on all nodes, is a more general mechanism. Use of caching techniques, which create a copy of the state on each node where the state was accessed, can lead to some similar behavior as what's seen with replication. One problem with this is that it requires consistency management. Now the state will be accessed concurrently on multiple nodes, and we have to make sure we coordinate those operations, as we said, to order all of the writes, propagate the most recent write operation to wherever or whomever is performing the next read operation. This is some overhead. One way to control the overhead is to perhaps limit the number of replicas, the number of copies that can exist in the system at any given point of time, since the consistency management has overhead that's proportional with the number of copies that need to be maintained consistent.